The cost of operating networks is too high. The current ratio of OpEx to CapEx for operators is greater than 5 to 1. Operators must reduce this ratio to stay competitive with the likes of Google and Alibaba by simplifying and automating the network operations. In order to achieve this, the operators require vendors to provide standardized interfaces for programmatic configuration of devices and multi-vendor networks that enable robust management via network-wide transactions and rollbacks. This is achieved by data model-driven management with standardized modeling using Yang and standardized data exchange using REST or Netconf protocols. REST is a better option for the NMS northbound interface for easy integration with cloud services. Netconf is a better option for the NMS southbound interface for robust integration with the network, as it provides network-wide transactions and rollbacks that REST does not provide. Netconf is short for Network Configuration Protocol. It is used to exchange data between the NMS and devices. It can be conceptually partitioned into 4 layers: Secure Transport Layer, Messages Layer, Operations Layer, and Content Layer from bottom up as shown in this figure. Netconf uses a client-server architecture where the client and server exchange and transmit data through the Secure Transport Layer. Currently, SSH is the most widely used transport layer protocol for Netconf. At the Messages layer, Netconf defines 3 types of messages: RPC and RPC reply, notification, and hello. The Operations layer defines 9 base operations invoked as RPC methods. It also supports user-defined operations. The Operations layer is contained only in the RPC and RPC reply messages, but not notification messages. At the Content layer, Yang is the most widely used modeling language. The NMS can use this mechanism to edit configuration data of network devices and obtain configuration and state data of network devices. Here we use the Agile Open Container, or AOC, as an example. The AOC functions as a Netconf client, and devices function as the Netconf server. Compared with conventional management methods such as SNMP and CLI, Netconf has the following advantages. Firstly, Netconf uses machine-to-machine interfaces, which have complete and standard interface definitions, facilitating the control and use of interfaces. Secondly, Netconf supports batch, packet splitting, and filtering operations, delivering higher efficiency. Thirdly, Netconf is very extendable. Fourthly, Netconf supports a wide variety of transaction processing mechanisms, including 2-phase, dry run, rollback upon errors, and configuration rollback. Last but not least, Netconf uses Yang as the modeling language of service models. Yang uses unified syntax rules, which is more standard. Some other Netconf capabilities worth mentioning are the distinction between configuration and state data, multiple configuration data stores, selective data retrieval with filtering, and event notification support. This slide shows edit configuration operations examples for Netconf and CLI, and mentions some core differences between Netconf and CLI. Netconf has one-time interaction with devices and one-time device parsing, therefore configuration sequence is irrelevant. CLI requires multiple interactions with devices and multiple device parsing operations, therefore configuration sequence is relevant, which complicates the automation. Netconf supports batch operations while CLI does not. The core difference is that Netconf and Yang provide a standardized approach, while CLI is vendor-specific. This slide shows the core difference between Netconf and SNMP. Netconf supports transactions and rollbacks, while undo operations in SNMP are done individually. Netconf 2-phase and dry run mechanisms can be used to quickly roll back the configuration data that has been delivered or even taken effect. In SNMP, when an operation fails, the NMS must perform the undo operation on the delivered configuration, which is complex and may generate junk data. In SNMP, the operations that have taken effect cannot be rolled back. In Netconf, an RPC message is sent from a client to request a server to perform a specific operation. The RPC element has a mandatory attribute message ID, which is a string chosen by the sender of the RPC that will commonly encode a monotonically increasing integer. The RPC and RPC reply elements are used in pair. RPC reply is a response returned by the Netconf server to the client and cannot be proactively initiated. The RPC reply element has a mandatory attribute message ID, which is equal to the message ID attribute of the RPC for which this is a response. If the device was able to satisfy the request, an RPC reply is sent that contains an OK element. An RPC error element is included in the RPC reply if the request cannot be completed for any reason. This slide shows an example Netconf RPC message and an equivalent CLI command sequence. This RPC message encloses a request sent from a Netconf client to a Netconf server to set the MTU on an interface Ethernet 0/0 to a value of 1500. This slide shows an example Netconf RPC error message and an equivalent CLI command sequence. The RPC error element is contained in an RPC reply element sent in response to an RPC message. In this case, the RPC error indicates an invalid MTU value for the interface Ethernet 1/1/1 in the corresponding RPC message. This slide describes 9 base operations defined by Netconf and 3 extended operations. This course focuses only on the most widely used 3 operations highlighted in grey. The getConfig operation retrieves configuration data only, while the get operation retrieves configuration and state data. The editConfig operation loads all or part of a specified configuration to the specified target configuration. This example shows a request containing a get operation and the corresponding response. The request contains a filter criterion which is defined to query the configuration and state data of interface ETH0. In the response message, the device fills the query result that meets the filtering conditions in the data node, which contains the configuration and state data of interface ETH0. Compared with the get operation, the getConfig operation can query only the configuration data of a device. In a request containing the getConfig operation, the source parameter specifies the configuration data store from which data is queried. There are 3 such data stores. The running data store is used to save configurations that have taken effect. The candidate data store is used to save data that can be submitted for validation, and the startup data store is used to save configuration data during startup. In this example, source specifies the running data store, and filter is defined to query information about all users. The device returns a response message containing information about all users to the Netconf client. The editConfig operation allows a Netconf client to edit configuration data of a Netconf server. This example shows a request containing the editConfig operation and a response message indicating successful operation. In the request, the target parameter specifies the configuration data store on which the edit operation will be performed. In this example, a running database is specified. The error option parameter specifies the action to take in case of an error occurring when the editConfig operation is performed. The value stop on error indicates that the editConfig operation is aborted upon the first error. The config parameter specifies the configuration data to be edited. In this example, the MTU attribute of the interface Ethernet 0/0/0 is edited. We can add the operation attribute to the model node at the content layer to achieve different purposes. The value of the operation attribute can only be merge, replace, create, delete, or remove. If the operation attribute is not specified, the operation is merge by default. The merge operation merges a specified configuration data node into the configuration data store. The replace operation replaces a data node in a data store with the requested data node. The configuration data identified by the element containing the create attribute is added to the configuration if and only if the configuration data does not already exist in the configuration data store. If the configuration data exists, an RPC error element is returned with an error tag value of data exists. The configuration data identified by the element containing the delete attribute is deleted from the configuration if and only if the configuration data currently exists in the configuration data store. If the configuration data does not exist, an RPC error element is returned with an error tag value of data missing. The configuration data identified by the elements containing the remove attribute is deleted from the configuration if the configuration data currently exists in the configuration data store. If the configuration data does not exist, the remove operation is silently ignored by the server. For more information about Netconf, refer to RFC 6241. Thank you.